Hey folks, this is Tobias from SideFX, and I just wanted to do a quick little tutorial today. I recently got a comment on my YouTube channel from a follower asking if I could show them how to do the Spider-Man web simulations in Houdini and also the Harry Potter wand effects with flip fluid. I'm going to skip over the Spider-Man one because I'm not really a big fan of that. There's probably a whole bunch of that kind of thing already on the internet. Same thing with the Harry Potter, but the thing that caught my attention was the flip fluid aspect of it. Had me thinking for a moment, and it was a good opportunity to bring up a couple of features in Houdini that might be well suited for this kind of thing that you probably hadn't thought of. So let me go ahead and close this. Now, I did actually look up some stuff from Harry Potter, and strictly speaking, this is a particle and curve based effect. So this really doesn't have much to do with fluids per se. Uh, that said, there are some things that you can see in the Harry Potter movie where you have kind of like this viscous fluid coming off of the power lightning bolts and stuff that are coming from the wands. Um, and that's the part I'm going to sort of focus on with this. So I'm going to take some liberty with this. I'm not going to recreate this effect because there's really no need for me to do that. This is pretty straightforward. But creating sort of a viscous fluid wand effect inspired by this would be a good thing to do. Now, the person that asked the question had specifically mentioned flip fluids, and I just want to talk about that for a moment. For an effect like that, you typically would want to use something other than flip fluids, because flip fluids in Houdini is really more for very large scale simulations. So things like oceans and all those huge effects that you see, with things breaching out of the ocean and all that kind of stuff, where you have a lot of heavy lifting that's going on. For a small effect like this, it's completely unnecessary to do something like that in flip fluids, because you don't want to have to set up a container with all kinds of stuff going on, and not to mention flip at the moment is pretty slow. We are working on improving that. So sometime in the future, that'll be better. But here's an alternative to do this. So like I said, I'm not going to reproduce the effect exactly as you saw in the screenshot. I'm going to give you sort of a foundational instruction here on how to create something similar and kind of cool, and do your own thing with it. So we're going to start with a sphere, which is going to be our source, right? And we're going to keep this as let's do a polygon, that way we get even distribution, and we can leave this the way it is. Now for sources, whenever you're doing particles or fluids or fire, pyro, and all that kind of stuff, you generally want to use something that's a little bit more interesting to look at than the sphere, or a box, or whatever it is that you're doing. So what I like to do is I like to do an animated noise on my source. So we're going to drop down an attribute noise and change this vector to position and range values to 0 centered. We'll lower this down here so it's not totally crazy, but then we're going to animate it. Here, let's lower this element size as well. Alright, and then we'll open this animation. We'll animate that. If we toggle our real-time toggle here, we can play this through. And you can see this is the effect that we're getting. If we lower the pulse duration, it'll go a little faster. So that's a little bit more energetic. So we'll use that. And that'll be our source that's driving the sort of fluid wand effect kind of thing that's going to happen. Alright, so as you can see, we're sitting right at the ground here, intersecting with the ground. So first thing we're going to do, just to help with the visualization here, is we're going to lay down a grid. This is going to be our ground. Now, what I imagine here is that we're going to do like a wand effect shooting down the, where we're looking at x-axis here. So let's make this really big. That way, and then just for the sake of good workflow, I could transform this right here using this, but it's easier, it's more sensible, I think, to just come in here and do this. So that way, if you ever want to edit this later, it's easier. Or if you're handing this off to someone else, it's really clear that this is being transformed this way, right? Okay, so this is going to be our floor, right? And then we're going to take a transform as well on this sphere, and we're going to say we're going to bring this up 5 units. Okay, and then okay, so this is going to be our source. And like I said before, let's do this with Vellum and not with flip fluids. The other advantage to this too is we get access to the OpenCL, which will utilize your GPU, which flip fluids does not currently do well. So anyway, I won't get into the technical details of that, but here we go. We'll drop down a Vellum fluid node, and it's already set to fluid. Pretty much everything you see here is kind of like what we're going to leave it at, although in my testing I did add viscosity and I did add surface tension. Now if you've ever used Vellum before, you know that when you use values here, they have to be really high to really kind of see the effect. So I'm going to go ahead and enter in just a couple of arbitrary values for now. And this pretty much sets up our fluid. And what's happening here is that it's changing. So we have little Vellum particles, right? And what I'm going to do for the next step is, if you look here, we have outputs for the geometry and the constraints. And I'm going to set up a solver that is going to take that information and do an emission on every subframe, right? Okay, so we're going to take this off to the side here. Now normally you would just plug these in here and do that, but we're going to do something a little bit more sort of intermediate, I guess. So first we're going to create a null just so we can access our geometry that's coming out here, which is the particles here, and then we're going to do our constraints. Same deal, null here. This is purely for making it easier to read in our tree when we're trying to access it later on. So we do have a collision geometry here, which is our floor, so we are going to wire that in, and then we're going to dive inside the Vellum solver, right? And this is where we're going to create pretty much some cool effects here. So we have two options here, force and source. One thing we need to do is make sure that we're having a constant emission from our source of Vellum particles, right? So what we can do is add a Vellum source, oops, if I can type, and wire that in here. And this is where we can change our emission type from only once, which is the default for all Vellum, to each substep. And our sources, we have a surface operator and a target path, right? So we need to add those two things we created nulls for. So we have geo, accept, and then our target is the constraint stuff, right? Okay, and then that's it. That's it for that. And then we're going to do two things in the force here to create the effect of the wand, or I'm sorry, the the fluid sort of ejecting out here, and then we're going to create like a little vortex, at the end of it. So two things we're going to do is we're going to do a pop curve force, right? Because what we're going to do here is we're going to create a curve in here that is going to suck the particles along, the Vellum particles along, and then after that we're going to do a what do you call it, axis force, pop axis force, yes, and then wire that in down a stream here and do that. So first, before we mess with any of these settings here, let's go create our curve. I probably should have said something at the beginning of this video. If you're using production version of Houdini, when you install it, just be sure to install SideFX Labs for this next part, because what we're going to do is we're going to create a spiral curve using the spiral tool in SideFX Labs. It's not that you can't do this in Houdini natively, it's just there's not a spiral curve model. You have to sort of write a little bit of wrangle to do that, and using the lab spiral just kind of, it gets you there much faster. So you'll see you'll have access to this node, and there we go. So by default it does this. What we want is something that goes straight up and down and spirals, right? So the height is the distance that we're gonna want to travel along for our effect. So you recall we created a very large grid plane. We wanted to kind of shoot across that. So let's say 20 meters, right? And then we're going to probably add a couple more loops, something like that. And we'll need to increase the scale, obviously, to really see the effect. All right, so this is what we have. This is sort of the rudimentary basic effect. Now you can adjust this as you see fit. I'm just doing this way for now, just to sort of show you quickly how to do it. Now, very carefully noted here, if you look, you can see we have 300 points, as the tool says. We absolutely did not need that for this effect. We can come down pretty low and still get a pretty good resolution. We just need a path. That's all we're doing, is we're creating a travel path for the vellum. And as with all sources, like I said in the beginning of the video, you generally don't want to just use the generic whatever is coming out of the tool, like a sphere or whatever. So we're going to do our simple little trick of creating some noise along the positions of each of those points. So let's go back up here, position, and again it's going to be zero centered, and it's a little aggressive, so we'll take that down, use a smaller element size, maybe something like that, and again we're going to animate it. And we want it to be kind of fast, so we're going to lower that number, and if you just want to test and see what it looks like, something like that. Maybe even a little faster. Yeah, there we go. It's more energetic that way. But we don't want it to sort of wildly, like we don't want to have a really high amplitude on this, because you'll get this crazy kind of stuff, and that'll matter in a second, and I'll explain why, because we're going to do a curve force in this, and if one of these points goes out of those boundaries, you'll have exploding particles and that kind of stuff, and that's no fun. So let's keep that like that. Alright, and now we're going to turn this thing on its head. So we're going to transform it. If you recall our sphere, we want to go down the positive x-axis. So what that means in 3D land is that we need to rotate this on the z-axis. So z 90. Right, and what I want is I want the small point on the beginning end and the large radius of the spiral to be on the finishing side. Right, so once I do that, now I need to move it back into where it's going to line up with our source. So that's at 0, and if you recall, our spiral was 20 meters high, so we're going to translate this 20 meters down the x, and there we go. Now we're back where we started, and we have a path. Although our sphere is 5 meters off the ground, so let's make sure that we're at least approximating where we belong, right? Okay, cool. So we have this, and this is the travel path, right? So we just created a motion path, if you will. That's going to pull the vellum along it. And then, just to see where we're at, let's take a look, and alright, so you can see we're lined up with our source, right? Now let's get into the solver and actually start pulling the vellum particles along the path here, right? So we need to activate this. Alright, so this is going to emit every subframe, and I'm leaving this on low settings without any substeps just to make it quick. So we have no forces right now, right? So it's just emitting on every frame. And this is going to be a little slow just because I'm recording the video, but it's actually a little bit faster than this when I'm not recording. So first thing we need to do, actually I made a mistake. Let's go back up to our geo here, and let's create a null for this curve. Okay, and we'll just call this out, oops, curve force. Okay, and that way when we're inside here, we have an easier way to find that. So the source for the curve is going to be force. Right, and there we go. And now we have an instant representation of what it is. Now the problem is that you can see by the arrows that the travel of this is going the wrong way. So what we're going to do is we need to reverse the curve, right? So let's go up here, and in our curve, if we look at our point numbers, it's going this way, but we want to reverse the sort. Actually, a sort. So we want to reverse the point order. So here we're going to, right after the spiral point sort, we're just going to reverse. So now it's starting from 0 this way and going up that way. And that should solve that problem. And let me get rid of these numbers. And it did not. Huh, interesting. Okay. Okay, so that was not necessary. Maybe this one is going to do the thing we need. Let's take a look. It did. Okay. So yeah, sorry about that. I thought that it was going by the actual order of the points. But that's not the case apparently. Okay, so we've reversed our direction, and you can always tell by this little black coloration at the end that this is the exit, right? So now what's going to happen is that we're going to drag these vellum particles along this path, right? So a couple things we need to do. First of all, let's just make sure that it works. We'll just hit play. Okay, you can see that it is doing something, but it's just really really not so exciting. Okay, we're going to fix that. So in the curve force node, we're going to increase these forces, right? Because this is where it really makes it work better. I like to try with higher numbers just to make sure that things are actually going to do what I want them to do. Okay, there we go. Okay, so some of that's a little crazy, but so what we can do here is, so clearly this follow scale is a little too high. So we'll bring that back, dial that back a little bit. Okay, so this is going to follow that. It's going to do all the twisty turns around it, and that curve is actually animating, so that means that the curve force is also animating. So it's like free noise turbulence without it having to really calculate too much, right? And then you can see when it gets to the end, we should give it a few more frames here, that curve force basically stops, and it just sort of lets go of those vellum particles to do what they want to do. And what we're going to do now is we're going to grab those once they are at the end there. So that's where this pop access force comes in. With this tiny little access force. I'm going to make this bigger first of all. I think I did that wrong. The height I wanted to be 5, and then the radius be 1, because we're going to create like a little flat sort of vortex kind of thing. So we need to change the direction instead of up and down to along the x-axis. I'm not quite sure why the responsiveness on this is so slow, but anyway, what we're going to do is we're going to take this pop axis force and we're going to move it down in front here. And I apologize for the sort of lagginess. Not sure if that's because I'm recording or what. But let's get into one of the orthographic views, make it a little easier to see what's going on here. So yeah, we're going to just move this right in front so that when these particles exit, we're going to sort of grab them into this field here. Right. Let's make sure our height is good on that. And yeah, okay, that's good. So let's get back here. So let's think about the shape of this vortex, right? So, oh, not what I meant to do. Also not what I meant to do. I want to scale this down. Okay, yeah, I don't have a 3 vector here. Okay, but anyway, let's work on our speeds here. So what I want to do is I want to grab these and suck these into this little vortex here. So that's our suction speed, which in my testing I actually had to use a low number, otherwise it kind of exploded out, just the same way they did in the curve if you have a really high suction speed. But what I do want them to do is to spin around in orbit a lot, so I'm going to increase that number a good bit. And okay, that's a good starting point, and let's just see where let's do this. 2.5. Yeah, that's more like what I want. Okay, so that's giving us a sort of like disc shape. Alright, and probably could be a little bit bigger, because I would like it to collide with the floor when they're spinning. Okay, so let's just see if this setup even works. Alright, so we have, let's just do a quick little review. We have our path that we made, which is this noisy little line that they're going to travel on, right? Then we have our source, which is this, right? And then we have just our floor with the going into the collision source for the Vellum solver. So then we just have a solver, and just at the very basic level, we should be able to see something resembling the motion that we want. Before I do this, let me change my background color, because this is probably really hard for a lot of you to see. So let's make that a lot easier to see. There we go. Okay, let me just increase this. This is way better now. Okay, sorry I didn't do that earlier. Okay, so it's being sucked along this travel path, and then when it gets to the end, we want to see it start to create like a little spinny vortex thing in place, though, not travel anymore. So let's get this down the way a little bit and see if it actually stops where I want it to stop, and just start creating like a little vortex energy. So like you can imagine a force sort of stopping it. So, say Harry Potter's on the other end here, and this is Voldemort, and the wands are meeting in the middle. So you could do this with an actual Vellum collision, but I wanted to just sort of like demonstrate just a real quick and dirty way to manage this. Okay, so our forces are a little bit, they're a little bit high, as we can see, but there's a number of things going on here that we get very quickly and without much fuss. We get an animated, sort of noisy force going on here. We have collisions with the ground, which is great, and then we have multiple forces, right? So we have this orbital sort of vortex force at the end, and we could sort of dial it in if we want. Let's just go ahead and do that now. So this was a little excessive, and what's happening here is the speed is probably a little aggressive, and we could probably come down on the size of this, the thickness of that there, and then we could probably move this a little closer to the actual source, so we don't get too much escape of the vellum particles. Let's try that. That's a little too close. 21. This is going to be different for you, just so you know. Obviously, these numbers are going to be different depending on your setup here, but what I want to do is just have the intersection be like right there. Okay, that seems like it'll work for me, and let's just sort of test how aggressive this is real quick. And I see this is turning into a little bit of a longer video. I was hoping this would be shorter, but I think it's important to be thorough and make sure that we actually show and cover the things that actually happen here. So I apologize for that, but I think it'll probably be worth it. Okay, a couple more seconds here. Okay, looks like that's starting to do what we want it to do. Now we're getting some of this escape here, which has to do with the radius of the curve influence and obviously the forces, right? So, and again, this is one of those things where we can adjust the forces as we go. So this is kind of cool looking. I mean, that's pretty exciting. And look at that. It didn't really take that long to set up. I mean, I made a couple of mistakes here along the way, and it's still only, what, 20 minutes or so. But if you were simming this in the flip fluid sim, you'd have to build more stuff going on, and a lot of different settings that are it'd be a little bit more difficult to get what you want quickly. Plus, you wouldn't have the advantage of the performance that you're getting with this here. So you're probably looking at this and going, great, but this isn't really fluid, you know. But we could solve that just by doing a fluid surface, particle fluid surface, because technically, all these particles are the vellum spheres are just particles, right? So now we're getting this, and we're back to a fluid kind of thing, and then we have all the advantage here of my vellum fluid, adjusting the characteristics of this, right? So if we wanted this to be more viscous, we could do something like 1,000, and surface tension could be probably brought up to like 200 or 250, just to get more of that webbing that goes on, but have it, be more thicker. Now I'm gonna go back to the vellum solver here because this particle fluid surface does need to calculate. So let's not do that right this second. Oh, looks like I'm having a. That was definitely a viewport glitch. That happens once in a while. You just have to click on the node to make it go away. Okay, let's see what we got. Give it a second. Give it a second. So we do have a little bit more viscous sort of thing happening, where it's more connected and thicker, kind of like sort of like plasma, which is a common thing you see in effects. So this is where this method differs from what you saw in the screenshot earlier. So you can see here, this is more of like, this is what I think the user on YouTube was actually looking for, was something that was a little bit more like plasma. Which is kind of cool. This is a much cooler look, I think, and it's not that expensive to do the effect. So you get all of this stuff for sort of free. So a couple things, a couple of tips. When it comes to rendering, I mean, there's all kinds of options. I tend to try to resist covering on that because there's too many ways to render this stuff with different render engines, and that's a whole video in itself. And then but anyway, what you can do is, you can use surface attributes like curvature and all that stuff to change, what's happening. And if you wanted to get really clever, you could figure out a way to grab the, the age of, the vellum particle in here, and write some vex code to remap that on a color ramp, things like that. But like I said before, if I were to let this play, we're getting collisions and all of that stuff. It's pretty cool. And this is completely procedural, right? So we can edit this path if we wanted to. We can even put in multiple paths, although that would probably break this, because I don't know, you're probably going to turn into a mess trying to do that. But this is a starting point for you to get what you're looking for, and be able to go back and just change how long is this, and blah blah blah. And in the curve forces themselves, you can change the behavior here. So I was talking about the radius of this here. So if you're getting a lot of explosions happening along the path, that's usually because your radius is too small on the not the pop axis force, the curve force. I'm looking at the wrong node, sorry. This right here, this max influence radius. So if this was too small, like say it was down to something like that, your particles would explode outside of it because it's not able to encompass it enough. So just a quick little tip there for stuff like that. And of course, like I said, shaping the path, you can easily do that here on this curve. Probably a good idea to look at this way, and then actually do this, and then adjust the radius to your heart's content. So if you want something that's suggestively spiral but not whatever, although this is a little bit closer to just adding a line and adding noise to it, so you might want to just sort of be more explicit about it being a spiral like that. Anyway, I'm starting to babble right now, so I think I've gotten you guys to the point where you have the fundamental down of how to do the effect. So you could just build similar systems like this, and you can see here, this is literally a handful of nodes. It's very not complicated to do, and I hope this helps you guys, and I hope you share some of the stuff that you create with it. It'd be awesome to see what you guys do. And again, this is Vellum, so take advantage of it. This is available for you in Houdini, and it works very, very well for this kind of stuff. Okay, good luck.